Remote sensing in erosion assessment. Soil erosion. Soil erosion is one of the most critical forms of land uh, degradation, degradation leading to the loss of fertile topsoil, reduced agricultural productivity, sedimentation of water bodies, and ecosystem imbalance. It is a complex process influenced by various natural and human factors such as rainfall, slope, vegetation cover, and land use practices and soil characteristics. A- Assessing and monitoring soil erosion over large areas using traditional field methods is often time consuming, costly, and labor intensive. The erosion challenge. Why modernized assessments? The need for modern approaches like remote sensing. The traditional methods of assessing soil erosion such as field surveys, sediment sampling, and manual mapping have been used for decades. While they provide accurate local data, these approaches face several challenges in modern environment monitoring. The modernization of erosion assessment through tools like remote sensing and geographic information system has become essential due to the following reasons like large scale and complex nature of erosion. Soil erosion is a spatially variable and dynamic process that occurs over vast years. Need for timely and repetitive data. Erosion process change rapidly, especially after heavy rainfall, deforestation, or land use change. The assessment of soil erosion using sensing involves identifying, quantifying, and sorry, and monitoring areas affected by erosion process through the analysis of satellite or aerial imagery. This approach allows for both spatial and temporal evaluation of erosion patterns, providing valuable insights for land management and conservation planning. A remote sensing based erosion assessment provides an efficient, cost effective, and repeatable method to study soil erosion dynamics. It supports sustainable land management, helps policymakers prioritize conservation efforts, and enhances our understanding of the relationship between human activity and landscape degradation. Core technologies. Remote sensing based erosion assessment relies on several core technologies that enable accurate data collection, analysis, and interpretation of erosion process. These technologies work together to map, quantify, and monitor soil erosion across different spatial and temporal scales. The first one, satellite remote sensing. Satellite imagery is the backbone of modern erosion assessment. It provides repetitive, large scale, and multispectral data for monitoring land cover and surface changes related to erosion. Digital elevation models. DEM represents the Earth's surface topography and are essential for analyzing slope aspect and drainage patterns. Uh, Unmanned aerial vehicles. Drones provide high resolutionary image for the site specific erosion studies. Leader light detection and ranging. Techno Leader technology uses laser pulse to measure surface surface elevation with high precision up to a few centimeters. The Geographic Information System (GIS) integrates, manages, and analyzes spatial data derived from remote sensing and other sources. It is vital for modeling soil erosion and visualizing results. Modeling and simulation tools. Remote sensing data feed into erosion models to simulate and predict soil soil loss under various conditions. Integrating RS with RUSL. The integration of remote sensing with the revised universal soil loss equation is one of the most effective and widely used approaches for quantitative soil erosion assessment. This combination allows for accurate, spatial distributed and up-to-date estimates of soil loss across large and diverse landscapes. Overview of RUSLM model is an empirical model used to estimate the average annual soil loss caused by water erosion. It is expressed as A is equals to R into K into LS into C into P. A is equals to average annual soil loss, R is equals to rainfall, erosivity factor, K is equals to the soil erodibility factor, LS slope length and steepness factor, C cover management factor, P support practice factor. Each factor represents a specific environmental or management condition influencing soil erosion. Remote sensing provides spatially continuous data to estimate several of these factors more accurately than field methods. The role of remote sensing in RUSL integration. The remote sensing data are used to derive spatial layers of several RUSL factors, particularly C, LS, and P, while also assisting in defining R and K indirectly through spatial correlation with rainfall and soil maps. Indices as erosion proxies. Indices and erosion proxies in remote sensing based erosion. In remote sensing indices and erosion proxies are quantitative indicators derived from satellite imagery that help in detecting, mapping and monitoring soil erosion related land degradation process. These indicators act as indirect measures of erosion intensity by reflecting vegetation condition, soil exposure, surface moisture and topographic features, all of which influence erosion susceptibility. Topography based indices parameter derived from digital elevation model DEM are vital erosion proxies because slope, flow direction and curvature determine runoff velocity and soil detachment potential. Coastal monitoring. Coastal monitoring involves the observation, analysis and management of dynamic coastal environments including shorelines, beaches, mangroves and coral reefs to understand natural process and human impact. Remote sensing has become one of the most powerful tools for this purpose, providing continuous, large-scale and multi-temporal data for detecting and analyzing coastal changes. Importance of coastal monitoring. Coastal zones are highly productive and densely populated regions but are also vulnerable to erosion, flooding, pollution and sea level rise. Continuous monitoring is essential for assessing coastal erosion and accretion patterns, tracking shoreline change and land sea interface shifts, monitoring ecosystem health, mangroves, coral reefs and sea grasses, detecting sediment dynamics and water quality changes, supporting coastal zone management and disaster preparedness. The role of remote sensing in coastal monitoring. Remote sensing offers multispectral temporal and sorry multispectral temporal and spatial data that allow scientists to analyze both natural and anthropogenic changes in coastal systems. Sustainable management. Sustainable management of erosion prone and coastal areas focuses on balancing environmental protection, development, and social well-being while preserving the long-term wealth and productivity of these fragile environments. Remote sensing and geographic information systems play an essential role in supporting sustainable management by providing accurate timeline and large-scale data for decision-making, monitoring, and planning. These are the image, image sources. You can check it out. Remote sensing has become an essential tool for accessing, monitoring, and managing soil erosion and coastal degradation in a sustainable way. It enables scientists and planners to observe environmental changes across large areas with high accuracy and temporal continuity. Remote sensing has emerged as a powerful and indispensable tool for assessing soil erosion, monitoring coastal changes, and supporting sustainable environments management. It supports sustainable management practices by monitoring vegetation, vegetation recovery, sediment dynamics, and ecosystem health, ensuring that human activities and development are balanced with environmental protection. Overall, the integration of remote sensing, modeling, and GIS provides a cost-effective, scalable, and adaptive approach to mitigating erosion and preserving coastal and terrestrial ecosystems for future generations. Thank you.